We are talking about perimeters and areas of similar figures. So we've talked a lot about similar figures in this class. Now we're going to focus on how the perimeters and areas of those figures relate to each other. So if you can get the ratios that go along with this lesson can be very simple. You just have to make sure that you're always thinking, is this a perimeter setup or is this an area setup? And if you can differentiate between those, you're in really good shape with this one, okay? Here's the first thing I'm going to show you. Let's say I have a triangle that has sides of 3, 4, 5, and then a triangle that has sides of 6, 8, 10, okay? If we look at that first triangle, what's the perimeter of it? It's 12, right? 5 plus 4 plus 3 is 12, whatever your units are. What's the perimeter of this bottom triangle? 24. Okay, now let's think area. What's the area of that top triangle? Right, 1/2 times 3 times 4, right? 1/2 times base times height. Or 6, and that's square units. What's the area of this triangle?
24.
1/2 times 6 times 8, or 24 square units. Okay, so we have a perimeter and an area, a perimeter and an area. Okay, now we're going to look at the relationship between them. So if I look at the perimeter ratio of these, so perimeter of the one to the perimeter of the other, it would be 12 over 24, which is really what? 1 to 2. Okay, so this is where we're saying perimeter of the first over the perimeter of the second. Okay, what if I said the area to the area? So the area of the top triangle is 6, area of the bottom triangle is 24. That reduces to 1 to 4. Okay, here's what I want you to see about that. If those are similar triangles, okay, which they are, these are similar triangles, the ratio of their perimeters is related to the ratio of their areas. Okay, so if my perimeter ratio is 1 to 2, do you see what happened to that 1 to 2 ratio to find an area ratio? What'd you do?
Because the bottom triangle has 4 times more area because it's twice as big. So it goes from 1 to 4.
Right. It has 4 times more area because it's twice as big, okay? That means that whatever my perimeter ratio is, so that 1 to 2, that value just got squared, okay? 1 squared and 2 squared, and that will get us our area ratio. Okay, so you don't even need to know lengths. If you know a ratio of their sides or a ratio of their perimeters, you can find the ratio of their areas by just squaring them. Okay, so that's the first thing we're going to talk about. Here's the deal. I'll write it this way. If the scale factor of two similar figures is A to B. Okay, so if the scale factor of two similar figures is A to B, then your perimeter ratio will also be A to B. Okay, think of it this way. If we look at this picture up here, my scale factor is 3 to 6, which is 1 to 2. My perimeter was also 1 to 2. Okay, so whatever your scale factor is, that will be your perimeter ratio. That'll be the relationship between the perimeters. Your area ratio will always be that scale factor squared. So A squared over B squared. And think of it this way. Area is always square units, right? Inches squared. That's what you're doing to the numbers as well. You're just squaring the numbers. Does that make sense? Okay, so let's say I gave you this example. I give you these two figures, a trapezoid with a 6-meter side, another trapezoid, a similar trapezoid with a 9-meter side, okay? And I tell you these are similar, okay? Meaning they are proportional. So I want to know 3 things. I want to know what's your scale factor. So what would the scale factor of these two figures be? 6/9, which is really 2:3, okay? Here's the biggest thing you need to make sure of on these problems is you have to reduce if you can reduce. Because if you don't reduce, you get some really crazy numbers later in the game, okay? So your scale factor is 6-9, but your answer is 2-3, okay? You have to reduce that scale factor. And I cannot stress that reduce thing enough, okay? Make sure that you reduce. All right, so if my scale factor is 2-3, what will my perimeter ratio be? What? Perimeter. 2-3, okay? I know nothing about the rest of these sides. Nothing. They don't tell us any numbers, but I can tell you right now that my perimeter, even without the numbers, is going to be 2-3 because my scale factor and my perimeter ratio will always be the same. Okay, so scale factor and perimeter ratio are the same. What will my area ratio be? Area ratio will be 4-9, right? We're just taking, actually, let's write it this way. We're taking that 2-3 and squaring both parts, which is 4-9. Okay, so scale factor, perimeter, identical. Area ratio, just square the first one. Okay? Okay, so then what can we do with a problem like this? Let's say we have 2 parallelograms. This is not drawn to scale, by the way. This is 6, this is 8, both are inches. And I tell you that the area of the larger parallelogram is 96 square inches. Okay, so this parallelogram has an area of 96 square inches. My question is, what is the area of the smaller? Okay, what's the area of that smaller parallelogram? We don't have enough numbers to find the area, right? We have a base, but we do not have a height on both of them. But we have an area for the bigger one, and we know how to find an area ratio, right? So if we have an area ratio, we can set up a proportion to compare our figures. So where's a good place to start? Do you know how to set this up to start the problem off? Get the perimeter ratio or the scale factor, right? Which would be what right now? 3-4. Okay, so our scale factor is going to be 6-8, which reduced is 3-4. Okay, so I know my scale factor. What do you have to do next? We don't need a perimeter one just because we don't need to solve anything about perimeter, but your perimeter ratio would be what? 3-4, okay, but we don't need it, so we're not even going to write it down. What do we need? We need the area ratio, okay? So my area ratio is what? 9-16. We're going to square these two. So my area ratio is 9-16. And here's the deal. If you reduced the first one, you won't have to reduce the later ones, right? Because it's already been reduced. And then once you square it, it can't be reduced anymore, okay? So 9-16 is my area ratio. how in the world do I figure out the area of the smaller figure then? What? Yeah. So I have a ratio. You said what equal?
The scale factor and the area ratio, right?
You're not going to set those equal because those are going to be different, right? The scale factor is like your A to B. Your area ratio, you're squaring. Michael.
Set 916 equal to x over 96.
There we go. Okay, here's the deal. 9 over 16 is our area ratio, right? We know the area of one of them. You have to be real careful about where you put that 96 though, because it has to correspond to the right figure. So my area ratio, it would be the 9 is associated with the smaller and the 16 is associated with the bigger one, right? So if I'm setting up a proportion, 9 over 16 has to be, you got to think, is it x over 96 or is it 96 over x? The 96 corresponds to the 16, so that's going to go here. And then we're going to put x on top, and that's going to give us the area of our other figure. What do you do to solve that? You just cross multiply. So you get 16x equals 864, and then you divide by 16. So x comes out to 54. 54 what?
Inches squared.
Inches squared. We found an area. Right? So 54 square inches. Okay, so if you have enough to find a scale factor and one of your areas, make sure you turn it into an area ratio first, and then once you have the area ratio, then you set up your proportion. Questions on that? No, that's not it. Not it. Still going. Okay. Next one. Okay, so this one says you have a plot of land that you harvested 13 bushels of some crop. What would you like to grow 13 bushels of? 13 bushels of carrots. Okay, so you harvested 13 bushels last year. So, I think this is a school project. That's what it is. So the school decides, we're going to give you more land this year because you did so great with it last year. We're going to give you more land to try to harvest more bushels, okay? So if you think about, you had some like rectangular plot of land that you harvested 13 bushels on. What is the 13 bushels? Is that perimeter? Is that area? Area, right? Because the bushels, you wouldn't just plot them around your figure. You'd fill the land, right? So 13 bushels is going to represent area, okay? It says next summer, they're going to give you a plot of land that is 2.5 times larger. Okay, so your new plot of land is going to be 2.5 times bigger. So 2.5 times bigger is this next plot of land. The question is, how many bushels could you harvest in that plot? Okay, so here's the deal. If something is 2.5 times bigger, is that a scale factor, a perimeter ratio, or an area ratio? It's a scale factor, right? It's 2.5 times bigger, okay? That's a scale factor. So that means that 2.5 to the original 1, or you could, maybe we'll flip that. Maybe it's less confusing if we flip it this way. So if it's 2.5 times bigger, that means our original was 1, right? 100%. Our new one is 2.5 times bigger than that, so 2.5. That's what I was just explaining to you. Want to try again? Okay. If your original plot of land, right, is 100% of what you had, that's 1. Okay? We're going to take that and we're going to go 2.5 times bigger. So 1 became 2.5, right? If it was 1 unit, now it's 2.5 units because we did time. Right. Gotcha. Okay.
Say again?
So here's the deal. We said this is a scale factor. But we said 13 bushels is an area. So if I'm going to use those 13 bushels as an area, what do I have to do to that 1 to 2.5? You got to square it, right? We got to make it an area ratio. So to make an area ratio here, I do 1 squared to 2.5 squared, which would be 1 to 6.25. So this is an area ratio. How do I figure out how many bushels we would get the next year if we harvested 13 the first year? What do you do? Two. Right. So this is an area ratio. Luca, quit. You have your area ratio. You set it equal to your 13 bushels, right, was an area of the smaller one. So you got to put the 13 on top and figure out what your new one will be on bottom, okay? And then you just cross multiply. So 13 times 6.25 comes out to, I don't know, 81.25. So if we're harvesting bushels, we would say you're going to harvest approximately 81 bushels the next year. Yeah, you don't harvest a quarter of a bushel typically. So, okay, questions on that? Okay, last one. Yes. What? You'd say about 82. Yeah, just round it. Okay, last one. This one says the areas of two similar triangles are 50 square centimeters, Emma, and 98 square centimeters. Okay, so we have two similar triangles and we have their areas. I want to know what's the similarity, sorry, we don't use that term anymore. What's the scale factor? Okay, and what's the perimeter ratio? Actually, let's just find them all. You're going to find it anyway. Okay, so we're looking for these three things: scale factor, perimeter ratio, and area ratio. What do you do? You're given the areas of two figures. What do you do? Luca, put it away. Zaire, quit watching him. What do you do? Are you raising your hand, Rachel? No. If you have two areas, you're essentially dividing them. You're setting them over top, right? You're making an area ratio. So if I have 50 to 98, that's going to be my area ratio. However, what should we do to that before we call it an area ratio?
Square it.
Reduce, right? It is area already, but you have to reduce it. So if we reduce this, it's 25 to 49. Yeah. Okay, so this right here is an area ratio. Okay, but I want a scale factor. Luca, sit right here. I want a scale factor and a perimeter ratio. What do I got to do? Yes, what is that? Square root, right? So this has been squared, area ratio, okay? You have to work your way backwards now. If we have a squared over b squared and we're trying to get to a to b, we got to square root that, okay? So we're going to square root 25 and square root 49, and we get 5 to 7. Okay, that's my scale factor. So scale factor is 5 to 7. What's the perimeter ratio? 5 to 7. Okay, so scale factor, perimeter ratio, and area ratio. Just the thing that you have to make sure of is that you reduce this. Because if you don't reduce that and you try to square root it, you get really ugly numbers and they won't be exact then. Okay, so make sure you reduce it first and then you can take the square root.
Just confirm the perimeter ratio is the same as the scale factor?
Yep, every time. Okay, do you need to leave, Sassy Pants?
Call them out.
Goodness, we are full of it today, aren't we?